Module 1, Introduction to Data Warehousing and ETL. Data warehousing and ETL are two essential components of modern data management and analysis systems. Data warehousing refers to the process of collecting and organizing large volumes of data from different sources, cleaning and transforming it into a format suitable for analysis and reporting. The data is stored in a central repository, known as a data warehouse, which enables users to access and analyze it efficiently. Extract, transform, and load (ETL) is a process used to extract data from different sources, transform it into a consistent format, and load it into a data warehouse or other target system. ETL involves multiple steps, including data extraction, data cleaning, data transformation, and data loading, which are automated using specialized software tools. The purpose of data warehousing and ETL is to enable organizations to collect, store, and analyze large volumes of data efficiently and accurately. By consolidating data from different sources into a centralized repository, organizations can gain insights into their business operations, customer behavior, and market trends. Data warehousing and ETL have become increasingly important as organizations have begun to generate and collect more data from various sources such as social media, IoT devices, and sensors. Effective data warehousing and ETL require careful planning and execution, as well as the use of specialized tools and technologies such as data integration software, data quality tools, and data governance frameworks. Overview of data warehousing and ETL. Data warehousing and ETL, extract, transform, and load, are two critical components of modern data management and analytics systems. Here's an overview of each. Data warehousing. Data warehousing involves the collection, storage, and management of large volumes of data from various sources in a central repository, called a data warehouse. The data warehouse is designed to support efficient data storage, retrieval, and analysis. It typically stores historical and current data from different sources in a consistent and integrated format. Data warehousing enables organizations to store and manage large amounts of structured and unstructured data, such as customer data, sales data, financial data, and other relevant information. Data warehousing also supports data integration, data transformation, and data cleansing processes to ensure data quality and consistency. Data warehouses often use specialized technologies and techniques such as data modeling, data indexing, and data partitioning to optimize data retrieval and analysis performance. Data warehouses may also include data governance mechanisms to ensure data security, compliance with regulations, and data privacy. ETL, extract, transform, load. ETL refers to a set of processes used to extract data from various sources, transform it into a consistent format, and load it into a target system, such as a data warehouse or a data mart. ETL processes typically involve multiple steps, including data extraction, data validation, data cleaning, data transformation, and data loading. The data extraction step involves gathering data from different sources, which may be structured or unstructured, and bringing it into a common format for further processing. The data validation step ensures that the extracted data is accurate, complete, and consistent. The data cleaning step involves removing any inconsistencies, errors, or duplicates in the data. After data extraction and validation, the data is transformed into a consistent format to ensure consistency and compatibility with the target system. Data transformation may involve data normalization, data aggregation, data enrichment, and other data manipulation processes. Key concepts and terminology. Sure. Here are some key concepts and terminology that are commonly used in various fields. 1. Artificial intelligence, AI, the field of computer science that focuses on creating machines or systems that can perform tasks that typically require human intelligence, such as visual perception, speech recognition, decision-making, and problem-solving. 2. Machine learning, ML, a subset of AI that involves the use of algorithms and statistical models to enable computers to learn from and make predictions or decisions based on data without being explicitly programmed. 3. Deep learning, a type of machine learning that uses artificial neural networks with multiple layers to process and analyze large amounts of data, allowing for complex patterns and representations to be learned. 4. Natural language processing, NLP, a branch of AI that deals with enabling computers to understand, interpret, and generate human language, including tasks such as language translation, sentiment analysis, and text summarization. 5. Big data refers to extremely large and complex datasets that cannot be easily managed, processed, or analyzed with traditional data processing tools. Big data often requires specialized techniques and technologies to extract meaningful insights and value. These are just a few key concepts and terminologies used in various fields. There are many more depending on the specific domain or industry you are interested in. Types of data warehouses. Data warehouses are designed to efficiently store, manage, and analyze large volumes of data for decision-making and business intelligence purposes. There are several types of data warehouses, each with its own characteristics and use cases. Here are some common types. 1. Enterprise Data Warehouse (EDW). An EDW is a centralized data warehouse that serves as the primary repository for data from various sources within an organization. It is typically used by large enterprises with complex data requirements, and it often involves a traditional on-premises architecture with data extracted, transformed, and loaded (ETL) processes. EDWs are designed to support data integration, data quality, data governance, and advanced analytics across the organization. 2. Operational Data Store (ODS). An ODS is a type of data warehouse that focuses on real-time or near real-time data integration and processing. It is designed to support operational decision-making and data integration from multiple sources in a more agile and flexible manner compared to traditional EDWs. ODSs are often used in transactional processing environments where real-time data integration, data enrichment, and data distribution are critical for operational processes. 3. Data Mart. A data mart is a smaller, specialized data warehouse that focuses on a specific business function, department, or subject area within an organization. Data marts are typically designed for a particular user group or department to support their specific analytics and reporting needs. Data marts are often created to provide a subset of data from the enterprise data warehouse or other data sources, and they can be either standalone or part of a larger data warehousing environment. 4. Cloud Data Warehouse. As mentioned earlier, a cloud data warehouse is a type of data warehouse that is hosted in the cloud by a cloud service provider. Cloud data warehouses offer the benefits of scalability, flexibility, and pay-as-you-go pricing, making them attractive options for organizations that want to avoid the upfront costs and maintenance efforts associated with traditional on-premises data warehouses. Cloud data warehouses can be used for various data analytics and business intelligence use cases, and they often support integration with other cloud-based services and tools.
Thanks for watching. For more information, like, comment, and subscribe our channel.